Assalamu alaikum dear students, hope all of you are fine. Today we are going to discuss the last part or last lecture of scalar and vectors. Here if you will go back in lecture 7, we have discussed definition of scalars and vectors with examples and the representation of vectors. Then in lecture 8 we have completed components of a vector and resolution and composition of a vector. Now today we are going for the last part, as I said earlier, addition and subtraction of vectors. As far as addition and subtractions are concerned, here we have the basic sort of definition. You can say that what is addition. So you can say that the process of combining of two or more vectors to produce a single vector, then a resultant vector, is called addition of vectors. And what we are doing here, you want to get a resultant vector or resultant effect of two vectors. Like if you have two forces and you want to know that what is the final effect of these two forces on a body, then you have to have a process of combining two forces, and that process will be termed as the addition of vectors. Now when we are going for the addition of vectors, we have certain, you can say, situations or conditions. Like suppose the first here is when vectors act along a straight line. And if suppose you have a body and the force on this body is say 5 Newton, and there is another force which is of say 5 Newton, then you can say that both of these two vectors are parallel and making an angle of 0, and they are of course in a straight line. So simply what you can say, okay, this is the simplest situation where vectors are in a straight line, and what we have to do, simply we have to add their magnitude, and the direction of the resultant vector is simply the direction of the two vectors. Yani you can say that f1 and f2, these are two vectors here. So simple thing is that the resultant vector, suppose f, will be simple addition of these two as far as the magnitude is concerned, and of course the direction of this vector is the direction of these two vectors. And suppose if you are considering x-axis and y-axis, then you can say that the forces are in x-axis, and as they are acting in the x direction of the x-axis, so the direction of the resultant is also along x-axis. So this is the simplest situation, you can say. On the other hand, if you have two vectors and they are slanting vectors, you can think in this way, that the vectors are making an angle, and they are not in this form, but one vector is somewhere here, another vector is somewhere here. So this is f1, this is f2, and they are making an angle of theta, which is of course not equal to 0 or 180 degree, because if you will go back to this example or this condition, here you have two vectors making an angle of theta with each other, which is equal to 0. So theta is equal to 0 in this case. But when you will have a condition like this, where two vectors are slanting vectors and making an angle theta other than 0 degree or 180 degree, then you can say we have to adopt certain special techniques or methods for the addition of the vectors. So there are basically two, you can say, techniques we can use. One is the geometrical methods or graphical method, and there are, you can say, certain methods in this first type. One is the head to tail method or rule. The second one is the law of triangle of vectors, and the third one is the law of parallelogram. First, I just want to discuss these three things one by one, and then I will come back to the analytical method. Here, as you are doing the geometrical or graphical method, then the first and the most important is head to tail method or rule we can use for the addition of two or more vectors. To add given vectors by head to tail rule, the following steps you have to follow. And suppose here you have the situation of two vectors, like here you have one vector which is say of 5 Newton, there is another vector which is of say 5 Newton or whatever the value you can take, but you have to consider a suitable scale. So as we have discussed before as well, that we cannot draw a vector or we cannot draw a line of 5 Newton, so we have to consider a scale. And suppose we are taking scale as 1 centimeter is equal to 1 Newton. So what will happen? 5 centimeter will be equal to 5 Newton. So we have to draw a vector of 5 Newton. It means that we have to take 5 centimeter length of vector A, and as the simple situation here, we have taken the value of vector B as 5 Newton. So both of them are equal, but the thing is that these two vectors you can say are not in parallel situation, but they are making an angle with each other. So what we can do, first of all, these two vectors are given. The second step you will do is take this vector B in such a way that it will coincide with the head of the tail of vector B will coincide with the head of the first vector A. So this is the situation. Here you have vector B, here you have vector A, and this vector, as I said, that drawn in such a way that the head of this vector will coincide with the tail of the other vector. The last step is that you will draw another vector in such a way that the tail of this last vector will coincide with the tail of the first one, and the head will coincide with the head of the last vector. So something like this you will have in this case. So this vector which you are drawing here will be the resultant vector. What you will do now? Simply you can say that you will measure the length of this R, and according to the scale then you will finalize that what is the resultant vector or magnitude of the resultant vector, and of course the direction will also be mentioned here. Like suppose in this case, if you are taking something like this, like suppose this is your x-axis and y-axis equation, here you have x-axis of course. So simply what you can say that if this is x-axis and y-axis, so the resultant is making an angle of 0 degree with the resultant is making a 0 degree angle with x-axis. So the angle you can also determine, but the main points here are the very important points. Draw given vectors on suitable scale. So you have drawn the vectors A and B. Then redraw the vectors such that head of the one vector coincides with the tail of the other vector. So this is the second point which you did here. Join the tail, third point is join the tail of the first vector with the head of the last vector, and this represents the resultant vector. So this is the resultant vector as I just mentioned here. R is the resultant vector, and the length, the last point are telling you that what will be the magnitude of the resultant vector. So the length of the resultant vector on the scale gives the magnitude of the resultant vector, and on the other hand the last part says, or the last point says, that the angle of the resultant vector gives the direction of the resultant vector. So I think it's clear. Here I have taken only two vectors, but you may have more than two vectors as well as two vectors. Like here we have mentioned that suppose one vector is here, one displacement is here. You say this is vector A or OA, then you have displaced from A to B. So this is another vector. Then from B to C. So this is another vector. Then you are coming somewhere here. So this is suppose C to D, and ultimately the situation is that the resultant vector you are drawing is this vector. So this vector will be the resultant vector, and what you will do, you have to draw this vector properly. So somewhere here you are, and the simple situation we can take this as somewhere here. So we can take this vector here. This is just an example, so we can draw it as we want. Suppose this is the situation, just leave it this point. So this is your resultant vector, and suppose this is say of displacement of say 4 meter, this is of 5 meter, this is also 5 meter. So this resultant vector will be the of course resultant effect or resultant displacement, and simply what you will do, as we have just mentioned, that the tail of the second vector will coincide with the head of the first vector. Similarly, the tail of the third vector will coincide with the head of the second vector, and the tail of your resultant vector will coincide with the tail of the first vector, and head will coincide with the head of the last vector. So in this way you are getting the resultant vector, and according to the scale, whatever the scale you are considering, suppose here you have the scale like this, that 1 centimeter is equal to 1 meter. So what you will do, 4 centimeter equal to 4 meter, 5 centimeter is equal to 5 meter, and then accordingly you will get the result or resultant, the magnitude, and of course the direction. As I have just mentioned, that if suppose you are taking axis in this way, and here you have the situation of x-axis, so each and every vector is making a particular angle, but as far as the resultant vector is concerned, simply you can say that this is the angle theta. Of course, vector OA is making an angle with the OB, and somewhere here suppose you can take in this way, the angle you can take in this way, that this is our theta 1 with the x-axis. Then again, if you are drawing a line here, then this will be the theta 2, but this is along x-axis. Similarly, if you have this line, this is your theta 3. So when you will finally add these three vectors with the help of head to tail rule, then ultimately the resultant which you are getting over here will make an angle theta with the x-axis. So these are the angles I have mentioned along with the x-axis, but you can also say that the angle between your say A and B will be somewhere here, and the angle between say AB and BC is somewhere here. So different situations you can consider, but the main point is that the resultant vector will have a particular magnitude and a particular angle. And of course, as I have already mentioned, that when you are taking any vector, like suppose resultant vector, so one representation is for the magnitude, and this you can get with the help of the scale which you have considered here. So this is something which is a graphical method, the first graphical method, and this is the head to tail rule. Now we have two more you can say methods here, and the second method is the law of triangle of vectors. This method is particularly useful for the addition of two vectors, and when we will consider forces in the coming chapters, then this method will be specifically very useful. What is this method? So simply you can state that if two vectors act on a body which are represented by two sides of the triangle taken in order, then the resultant vector is expressed by the third side of the triangle in opposite order. Yani you have two vectors, this vector is A and the addition with the B, then you can say and see that this is one order, but the resultant vector will be the third side of the triangle in the opposite order. So this will be the situation of the law of triangle, and as I said that particularly when you are considering the situation of forces, this will be a very important method. Particularly like suppose if you have balance situation or equilibrium situation, then you can say that these two forces, suppose this is F1, this is F2, and here suppose you have F3. So what is the resultant here? You have started from point O and you have gone to A, from A to B, and then you are coming back to O. It means that the resultant vector is 0. There is no resultant. And when resultant force is 0, so you can say the body will be in equilibrium. So this type of application we have, and in a number of cases, particularly as I said that in case of forces, this will be a very useful method, and this is termed as the law of triangles of vector. Similarly, we have the third method, which is law of parallelogram of vectors, and this method actually again is for two vectors, and we have studied this method in your IDCSE as well, or O level you can say. What is this method? So simply you have this statement: if two vectors act on a body which are represented by the two sides of the parallelogram such that their tails coincides, then the resultant is represented by the diagonal of the parallelogram drawn from the initial point of the given vectors. Yani what is the situation here? Simply you can say we have one vector A, another vector is B, and these two vectors are making an angle theta. Then we can draw a parallelogram in this way, that we are drawing a parallel vector A over here and a parallel vector B. So when you will draw these parallel vectors A and B, so what ultimately you will get? You will get a complete parallelogram. And in this case, what we are saying that the diagonal of the parallelogram will be the resultant in such a way that the tail of the resultant is coinciding with the initial point of the given vector. So this is the initial point. Say suppose you can consider that this is P, or this is say Q, S, T. So from P to Q you have vector A, from P to T you have vector B, and you can draw QS as a B and TS as A, and in parallel to A. And as I said earlier that the diagonal of the parallelogram will give you the resultant. So this is something which is important. So these are three methods. One is the head to tail rule, second is the law of triangle, and the third is law of parallelogram. And basically, as we have just said, that all these are basically geometrical or graphical method. Yani you have to use scale and pencil or pen to draw, and you have to have a say a protractor because you want to measure the angle as well. So this is termed as the geometrical method or graphical method. So in this case you have to draw these lines accordingly, and ultimately you will get the resultant vector. So remember these three methods as far as the geometrical methods are concerned. Then go back to the initial point, and here we have the second method, which is the analytical methods. In case of analytical methods, we need not to use any scale or pencil or whatever, but here we have to use a calculator, you can say, and we have two you can say situations here. One is that we are using the law of cosine and sine laws to add the vectors. So what we have the situation here, two vectors we are considering, and these two vectors, suppose if two vectors A and B act upon a body such that their tails coincide, then the magnitude of their resultant R is given by law of cosine. And suppose here you have this diagram, and you can say that we have two vectors A and B, and their tails are coinciding, and they are making an angle of theta with each other. Then what will be the situation? Law of cosine we can use, in which the resultant R can be calculated by using this formula. I am not going for the derivation of this formula. We can do it, but for the time being is not important. This formula you have to remember, but remember this point as well, that this formula will be valid when two vectors are drawn in such a way that their tails are coinciding, and of course the theta between them is angle theta is in between them, you can say. So here you have R is equal to square root of a square plus b square plus 2ab cos theta. Remember this thing, that this plus is important when you are considering this situation and the tails are coinciding. Again, this R is just giving you the resultant magnitude, magnitude of the resultant vector, but when you have the situation of theta, so you need to use the law of sine. So law of sine says that sine phi over b is equal to sine 180 degree minus theta divided by r. So this is your r. Here you have the angle which we are considering, the angle which your resultant vector will make, and this is your phi. So if you are considering this angle, so this will be the 180 degree minus theta, and simply the sine theta, sine 180 degree minus theta is equal to sine theta. Remember this point. So if you are considering this angle, then simply you can write that sine phi divided by b is equal to sine theta divided by r. But if you are considering this angle, then of course you have to consider sine of 180 degree minus theta, and this will be your angle here. And of course, what is the situation? This angle, basically the angle opposite to your resultant vector, and this particular side is opposite to theta. So sine theta over r, here you have this situation, sine phi divided by b, and then you have this value which is sine 180 degree minus theta, and the opposite side is r. So the sine law is giving you the required angle, yani you can calculate the required angle theta with the help of this formula. So this is what we have as far as the law of cosine and sine is concerned. But here we have a very small change, and you must remember this point, that if the vectors are given in such a way that they are following head to tail rule like this, that the head of vector, suppose A, is coinciding with the tail of vector B, and here you have the angle, then this will be of course the resultant, but the magnitude then you have to calculate with the help of the formula, which is nearly same as before, but the sign over here is different. This is negative sign. So for the calculation of the resultant vector, remember this thing, that if head to tail rule is being followed in such a way that the tail of the second vector is coinciding with the head of the first one, then the cosine law will have negative sign over here. But in case of tail to tail coincidence, you can say that the formula will be this one, yani with positive sign. So this is something which is very important. Here the formula, which is the sine law, is simple: sine phi divided by b. This is not sine b, this is only b. Here you have sine phi, this is phi, opposite side is b, and here you have the theta, opposite side is r. So the formula is simple: sine phi over b is equal to sine theta over r. So this is something which is the first technique, you can say, for the analytical method using law of sine and law of cosine. And one is giving you, yani law of cosine is giving you the magnitude of the resultant vector, and the law of sine is giving you the direction of the resultant vector. So remember these two formulae and these two conditions. When the tail are coinciding and when head to tails are coinciding, so a little change over here, and this will be the change of positive and negative of these you can say sign over here. So be careful. Last but not least, we have another very important method which is termed as using rectangular component methods of the given vectors. In this case, what will happen? You have to find out, and suppose you have two vectors, say here you have one vector, I can draw, here you have one vector, say vector A, which is making an angle here you have the situation, the angle is here, this is your theta, the one you can say for your vector A. Then here you have suppose another vector which is say vector B, and vector B is making another angle which is say theta 2. So in this case, what you have to do, you have to consider their rectangular components, and you will resolve given vectors into their rectangular components. Like suppose this is your say a1y and this is your a1x, as we have discussed the rectangular component before as well. So I'm just quickly completing this part. Here you have b2, or simply you can write here not a but b, so by, this is your bx. So even here you can write simply ay and ax instead of a1, so as we are considering a and b. So these are the two situations. So ultimately what you have to do, you have to consider or you have to resolve the given vectors into their respective ax and ay components, and then what you can see that ax and bx will be in the same direction on the x-axis. So you will add the x component of the given vectors, and in this way you will get the x component of the resultant vector. So if suppose you have n vectors, if you have n vectors, so what you can say that Vx will be equal to the sum of their respective x components, and V1x, V2x and up to Vn x you will add, and you will get the x component of the resultant vector. Similarly, as you have this formula, Vy is equal to V sin theta for the y component of vectors. So by using the values over here, you can find out the y component of your vectors a and b suppose, and then what you will do, you will add these components, and ultimately the result is nothing but your y component of the resultant vector. So as you have now the x component of your resultant vector and y component of the resultant vector, which you are getting from their respective x components and y components. So ultimately you can use this formula, v is equal to vx square plus vy square. This is for the magnitude, as we have done before as well, and this formula you can use for the angle of the resultant vector. So when you have to use this method, any rectangular component methods, then what you have to do, you have to resolve given vectors into their respective x and y components. When you will add all x components, then the x component of the resultant vector you can get, and when you will add y components of all vectors, you will get the y component of the resultant vector. Ultimately, as you have done before in lectures 7 and 8, v is equal to square root of vx square plus vy square will give you the magnitude of the resultant vector, and with the help of this tangent theta is equal to vy over vx, or simply you can say that tangent theta is equal to inverse of tangent vy over vx. You can get the angle of or direction of the resultant vector. So this is something which you will use in the coming chapters. Normally you will see that you do not have direct questions on vectors, but the application of vectors are of course here in our syllabus. So this is very important that you can use this thing, and you must know that what is the situation and how you have to use these things. So I hope you have this understanding, and as I said that when the application will come, then we have to apply these methods, one of these methods which we have discussed here, and hopefully you are getting what we have discussed. Here we just want to know the subtraction of vectors as well. Subtraction of vectors is nothing but the addition of vectors with the negative sign. Like suppose if you have a situation like this, that you have one vector A in this direction, and there is another vector which is suppose B in this direction, and you want to get the subtraction of these two vectors, yani A vector minus B vector, which will give you vector C. So what you can do, simply you can say that actually we are going to add these vectors, but the difference is that we are adding vector A and B in such a way that the negative of B is going to be added in vector A. Yani what is negative of B? So simply you can say that if we have this vector B, then negative of B will be the vector which is equal in size or magnitude but opposite in direction. So this will be your negative B. So what you have to do, nothing but if you have this vector A, and as we have just drawn, this is your vector B, which is the negative vector, sorry, this is vector A, and here you have negative B. So what you can do, you can draw, suppose you are using the head to tail rule, then you can draw the vector in such a way that this is in opposite direction. So this is your negative B. So what actually you have done, you have added these two vectors through your head to tail rule, and the resultant vector you have to say you can say situation, yani the resultant vector will be a vector which is from the tail of vector A to the head of vector B. So this will be your resultant vector. So no a big change, but you can say that this is vector C in our example. So no big change, but only one thing. Any subtraction of vectors is simply the addition of negative vector in the given vector. Yani vector A and vector negative B, when you will add, basically you are subtracting vector B from A. Similarly, if you want to subtract vector A from B, so what you can write here, that suppose the situation is that B minus vector A. So in this case, what will be the resultant? So simply you can say that we are actually adding negative A vector in our vector B, and we are getting the resultant. So in this case, what will happen? You have the situation, yani B vector is in the same direction as before, and this is your say first vector, which is B vector. But as far as the A is concerned, here you have to consider the negative of A. So this negative of A you will add here, and you can say that something like this. We have this vector A. So this time we are following this route, that this is B and this is A. So ultimately, what is the situation here? So you can say that the resultant vector will be somewhere here, yani from the tail of the first vector to the head of the last vector, and this will be the situation over here, that this will be the resultant vector. So in this case what we are doing, or the situation is that we are subtracting vector A from B. So the negative of A is being added in the positive, in basic vector B, and the resultant will in the opposite direction. Here you can say and see that the resultant vector is in this direction. If you are suppose considering here the x-axis and y-axis situation, then you can very easily get where your resultant vector. In this case, here you have this situation. So this is x-axis, and here you have y-axis, negative x, y, negative x, y, here you have y dash. So you can say and see that if the A minus B was somewhere here in between your coordinate, your lines y and x dash, then in this case what will be the situation? The resultant vector will be in just opposite direction. Why? Because here what you have taken your B as positive and your A as negative. So you can say that the resultant vector will also be a sort of negative of your first vector. So this is just opposite to each other. So simple thing is that what we can write for subtraction of one vector from the other vector is simply the addition of negative vector of a vector to the first vector. Simple statement. Yani when you are going to subtract a vector from the other, you have to consider first of all the negative of the second vector, like in this case, or negative of the second vector in this case. Yani case 1 is here and case 2 is here. So simply you can say that these are two possibilities, and we can say and see that the resultant vectors are in just opposite direction when we have the opposite operation. Yani A minus B and B minus A, the resultant will be just opposite to each other. So this is what we have as far as the subtraction of the vectors is concerned. So inshallah, till the next lecture, Allah Hafiz, take care.